put your hands together for Marc Delcourt, CEO at Global Bioenergies. We will dive into the IBN-SPK, a new technology to produce sustainable aviation fuels.
So yeah, I'm going to send you in a completely different space, sustainable aviation fuel. Maybe before I start talking in more details, I'm going to tell you a bit more about Global Bioenergies. Next slide, please. So we're a listed company, so we need to put this little disclaimer. So we're an old startup, so we've been funded in 2008. We're about 50 employees. We're listed on Euronext. And what we've done is only one thing. We have developed a process to produce bioisobutene, which is, in fact, isobutene is one of the molecules lying at the core of the petrochemical industry. And for the first time, we can produce it from different feedstocks, renewable feedstocks, such as sugar beet or wood chips. So we do petrochemistry from renewable feedstocks. We're at the crossroads between synthetic biology and green chemistry, and our aim is really to cut CO2 emissions. We're early commercial. We generated 3 million euros revenue last year, and we have great plans to deploy our technology. In fact, the main application of our technology is in sustainable aviation fuels. We can produce fuels that is really looking like kerosene, but it is produced from renewables, and it produces less CO2. We also have a niche market, surprisingly, in the cosmetics, and we are harnessing this opportunity together with L'Oréal. So it's kind of a stepping stone to move to the large market of sustainable aviation fuel. So why are we doing all this? So you know that the planet is boiling. This is the last point which has been added yesterday by Copernicus. So we're 1.6 degrees higher if compared to the pre-industrial era. That's really awful. This was absolutely unpredictable 1 year ago. It's really accelerating. And in fact, aviation is a part of it. This slide shows where is the CO2 produced. So you see it's produced in China, it's produced in Europe, it's produced in the US, but it's also produced by all the airlines that are crossing the various oceans. If you look at what IATA says, the International Organization for Air Transportation, they say there is only one solution, sustainable aviation fuel. It's going to be 65% of the solution when we're going to decarbonize aviation. And what we've done is a process which is based on bacteria. So we have engineered bacteria, and these bacteria are converting carbohydrates, such as sugar beet, into hydrocarbons, which are usable as sustainable aviation fuel. So it's a unique process. It's been completely different if compared to what has been produced in the past. Isobutene is a gas, so it volatilizes spontaneously from the broth. It brings a lot of advantages. And if you look now at the complete technology setting, so we convert the sugar into isobutene, and then just by combining these molecules 3 by 3, it's very easy, three very easy steps, you end up with sustainable aviation fuel. And this is the most direct route from renewable feedstocks to sustainable aviation fuel. So if you look at what is existing in the sustainable aviation fuel, you have only one technology which is commercial. It's based on waste cooking oil, produced at small volumes, and it will plateau soon because we cannot produce more waste cooking oil in the world. Then you have one technology which is expected to be next. It's ethanol to jet. It's just starting. The first plant has been built and is presently commissioned. We see ourselves pretty much in the same box if compared to ethanol to jet, because we're also based on microorganisms. We're also using sugars. We're a little less advanced. We're just starting our commercialization, and we have a plan to build a big plant for 2027 and then to deploy in 2030. And then you have other options which are less advanced and might be a part of the future, especially e-fuels, which is a starting story. So if you compare our technology, IBN-SPK, to ethanol to jet, you see that we're a match. We have a smaller number of steps, so it's shorter route. Is it going to translate into lower cost? In the Excel spreadsheet, the answer is yes, but now, of course, this will have to be proven in the facts. We have our roadmap says that we're going to deploy in various geographies our technology. We have 4 project plants, 4 plants project moving on, targeting 2030 as a starting date. And this happens on the boiling market. So the reference in the field named Sky Energy, they're saying that in their latest market survey, they're saying that the market is going to be exceeding 12 million tons in 2030, in 6 years. Today, it's only 0.5 million tons. So you see, it's going to ramp up like crazy. So we're going to be part of this. This is a complex slide, but if there is only one thing to say is that our molecules have a specific property. It also, not only it's a very good fuel, but it also acts as an anti-freeze. So it's very low boiling point, and this has value, additive value, meaning higher prices. This is part of our opportunity. This is the next plant we have in our project. So we're in the engineering phase here, and we're going to build this plant for it to start in 2027. This plant will target the niche markets where the prices are very high, especially the cosmetics and also a little bit the motorsport. And we expect that the plant will be experiencing an IRR of 30%. Today, it's in fact already fully, it's oversubscribed in terms of purchase agreements. In fact, it's preliminary purchase agreements, letters of intent. But we have pre-sold more than the capacity of the plant. So we see a very strong commercial traction on these niche markets, and this is really the starting point for the industrialization of our technology, which will then deploy in larger markets such as sustainable aviation fuel. Thank you for your attention. I think I'm done with my presentation.